Figure 2 shows a sketch of part of the curve C with equation y equals x ln x. That's this one that, it looks a little bit like a quadratic, but it's not a quadratic, x greater than 0. And then L is a normal at the point EE. This region we're asked to find the area of, and we're asked to show the exact value is this. Okay, right, I'm going to need to find out where these 2 points are. For the first one, it's where x ln x is equal to 0. Now, x itself can't equal 0. It's kind of going towards 0 there, but the next point then is going to be when x is 1, because that is when ln is 0. I suppose if you're trying to solve it technically, it'd be x ln x equals 0. We know that x is not 0, so we can just divide through by it. And then it's going to be x is e to the 0, which is 1. Okay, there's different ways you can get it. So what I think I'm going to do is go straight for this red region. I'll call it R1. R1 is therefore going to be the integral from, remember this is e here, integral from 1 to e of x ln x. Okay, and to integrate this, we do by parts because it's a product of functions and both, well, actually ln x is not easy to integrate, or you have to do it by parts itself, but that's the one that we let equal to u because it nicely differentiates and will become 1 over x and then will cancel out. And this is the route to follow. The word late helps you out. So when you're integrating by parts, if you have a log, that is pretty much always your u. And then we do an algebra one. So if we had x sine x, then we would let x equal u. And then although these are not common in A level, it's then trig and then exponential. So try and remember that little helper if you're integrating by parts, which one to set equal to u. Because if you choose the wrong option, it can make things worse. So u dash is 1 over x, and v is a half x squared. The formula for this is given in the formula book. It's uv evaluated between our limits minus, again, our limits here, u dash v. So for us, it's going to be ln x times v, or half x squared times ln x. I'll just write it the other way around. Minus the integral of u dash v. So that's 1 over x times a half x squared. That is a half x integrated. I'll substitute this bit in, so I'll get a half e squared ln e, which is 1. And then I'm actually minusing half times 1 squared times ln 1. That just becomes 0. And then here I will get a quarter x squared evaluated between e and 1, which gives a half e squared minus a quarter e squared. This is in a bracket, it becomes plus a quarter, and therefore I've got a quarter e squared plus a quarter as my R1 area. So now just need to find R2, and I'll need the equation of the normal for this. So to get the normal, I need to differentiate. So y is equal to x ln x. Okay, now to differentiate, I need to use the product rule. So this is u, this is v. The product rule is u dash v plus u v dash. U dash is 1, v dash is 1 over x. Just differentiating both of these. So dy by dx is u dash v, so that's ln x, plus u v dash. That's x times 1 over x. So I just get ln x plus 1. The other way to do it is just to say, right, it's going to be x times the derivative of ln x, that's r1, plus the derivative of x times ln x, that's our ln x. So when x equals e, dy by dx is going to be ln e, which is 1, plus 1 is going to be 2. And this is not the gradient of the normal, it's the gradient of the tangent. Tangent, remember, would have exact, just going to sort of draw a line in. Wasn't that great? It's just going to glance off of the curve at that point. It's going to have the same gradient. And therefore, the gradient of the normal is going to be the negative reciprocal because they're perpendicular. I know I'm kind of assuming a lot of things here that you know how to do. This is question 13. If you're struggling with any of it, then go back and try some questions where they just do these skills in isolation. Because we've already integrated by parts, including a Lun. We've differentiated using the product rule. We've had to use logs throughout that, and now we're using the gradient of the tangent and the normal. So now we can find the equation of normal. Y minus y1 is x minus x1. This is, sorry, m. I'm rushing it now. M x minus x1. I would advise this one. You can use y equals mx plus c if you prefer. So y minus e, because remember that's the point that the normal's going through, is equal to minus a half x minus e. I'm not actually too interested in the equation normal itself. I want when y is 0. So when y equals 0, minus e is equal to minus a half x minus e, which means that 2e is equal to x minus e. I've times through by minus 2, and therefore x is equal to 3e. Okay, that was what I was really interested in. And R2 just falls into place now because we actually have a triangle. We do not need to integrate that normal. That's just a bit unnecessary. We can see that the base is, I'm going from e to 3e, so the base is 2e, and the height is e, because remember that point there is e. So R2 is a half times the base times the height, which becomes e squared. Finally, total area is our area from before, a quarter e squared plus a quarter, plus this e squared that we get for the R2. Bring that together to give 5 over 4 e squared plus a quarter. I've actually done, I don't think I've used my calculator at all in this question. Be careful if you start using your calculator because it won't keep it in terms of e. It can manage with pi, but I don't think let's just double check. If you do like e to the 0, then, sorry, not e to the 0, e to the 1, then it's not, whilst it's like pretty familiar with pi and doing things like that, as soon as you put e into your calculator, it doesn't work out. So I would personally just work in terms of e throughout, like I've done here, and then it all checks out. Nicely done.